Hello and welcome to the week 4 extra exercises walkthrough video. This week it's all about our loops, our repetition structures, as well as working with different types of data containers for organizing our data. As with week 3, you'll notice that the video is kind of made up of a few different recording sessions, and again that's just as a result of when we moved from semesters to trimesters, I sort of moved the videos around a little bit so that it still followed a nice logical order. So again, the chapters will line up with the task sheet that you've got in front of you. So just follow that through and yeah, hopefully that'll all be pretty clear. Enjoy the rest of the video. So I've got a little bit of a warm-up exercise at the start to get our brains warmed up. So I've actually copied this code into a script in MATLAB and we're going to look at what the output will be for the following code. So to do this question, we basically need to trace through the values of the variables because in the last 3 lines, those values are being displayed. So we can have a look at our code. On line 1, A is being set to 50, so that one's pretty straightforward, and on line 2, B is being set to 2. On line 3, we're actually taking the variable A and we're setting it to the value of A times B. So setting it to the value of 50 times 2, which is equal to 100. So after line 3, A is now equal to 100. And on line 4, we're creating a new variable called C, and we're setting it to A, which is now 100, times B, which is still 2, which gives us a value of 200 saved inside C. And then on line 5, we're taking our variable C and we're changing its value to be A, which is 100, plus B, which is 2, plus C, which is 200, which gives us 302. So when we run this code, we should see that A is equal to 100, B is equal to 2, and C is equal to 302 based on this variable tracing we've done here. So we need to save it first. We'll click run. I'll save it on my desktop, week 4 demo. And then if we swap over to MATLAB, we'll see that that's printing out those 3 values. So we've got our value of 100, 2, and 302, just as we expected. So that was our warm-up exercise, pretty similar to an exercise we did in week 2 actually. So the next one is vector creation. So what would be the output of the following code? The no semicolons at the end means that the values will actually be displayed. So for vector 1 equals 1 to 10, that's going to actually print out the numbers 1 to 10 in steps of 1. So it'll say 1, 2, 3, 4, 5, all the way through to 10. I'll actually show you what that looks like actually. So let's just get rid of this stuff. Vector 1 equals 1 to 10. Run that code. And if we have a look at MATLAB, we can see that that's the output that we were expecting. The next one, vector 2, 1 to 3 to 20, that's going to go from 1 to 20, but in steps of 3. So it'll go 1, 4, 7, all the way through. And it'll finish kind of at the last number that's less than or equal to 20. So if I type in vector 2 equals 1 to 3 to 20, I might actually put a semicolon at the end of that first line now because we only really need to see the second line. So I've just run that and we can see that it goes 1, 4, 7, 10, and it goes all the way up until the sort of the last number that's less than or equal to 20. So it stops at 19 in this case. Vector 3, 10 to negative 1 to 0. So this is actually going to start at 10 and go to 0 in steps of negative 1. So it's going to count down from 10, 9, 8, all the way through to 0. So I'll have a look at that one in action. I'll add a semicolon here actually. So 10 to negative 1 to 0. Run that. And you can see that it's counting down from 10 to 0 in steps of negative 1. So effectively for these first ones, the important thing to know is that we need at least a start and an end point for our vector, but we can also specify a step. So if no step is specified, it's just assumed to be 1. But if you want to specify a different step, you put it in the middle. So that's our step there, and that's our step there for those 2 different ones. In vector 4, we've created this 9145 vector and we've put this little apostrophe after. That just means that it's going to be vertical down the page rather than horizontal across the page. So we'll have a look at what that looks like. So the little apostrophe is like a transposition function. So it just flips it. And if we kind of wanted to flip it back, we could then also do vector 4 transposed with a little apostrophe again, and it's going to transpose it back into the regular form. So you can use that one to sort of manipulate variables to be in the same shape, which becomes important when you start to do maths and stuff like that with multiple vectors. So that's where the transposition function can be handy. So that's creating vectors. Hopefully that's reasonably clear. The next thing we're going to look at is some logical statements. So each of the following code snippets includes code for logical and, or, and not operations. Based on the values of A and B, write what the output would be for each code snippet. Note that MATLAB considers 1 to be true and 0 to be false. So if a value is equal to 1, that's true in MATLAB language, and 0 is false. So this first one here, we've got disp A and B. So we're seeing if A and B are both true. In this case, only A is true, B is false. So the AND statement will return false, because remember, it only returns true if they're both true. Meanwhile, the OR statement, so this line 5, disp A with the little vertical lines, that's saying A or B. So if A or B is equal to 1, this whole thing will print 1. So that's going to print 1 because A is equal to 1, even though B is equal to 0. The last one, display little squiggly line, I think it's called tilde A. That is going to pretty much just flip the value of A. So because it's 1, it's going to actually display 0, which is the opposite in terms of Boolean logic. So we'll actually type that up and have a look at it in action. So if we've got A equals 1, B equals 0, disp A and B, disp A or B, and disp not A. So let's run that code. And if we have a look at MATLAB, we'll see that the AND statement returned false, the OR statement returned true, and the NOT statement returned false, which is what we expected based on the values of A and B. So have a look at the next one. We've got A equals 0 and B equals 0 this time. So the AND statement is going to return false because they're both false. The OR statement is also going to return false because they're both false. And the NOT statement will return true because A is currently false. So it flips that value. So again, we can tweak that quickly in here and run the code. And we'll see that that is what we get. So we get false for the AND statement, false for the OR statement, and true for the NOT statement. The next one has 1 and 1. So the AND statement will be true because they're both true. The OR statement will be true because at least one of them is true. And the NOT statement will be false because false is the opposite of true. So 1 and 1. And if we run that, we see that we get true for the AND, true for the OR, false for the NOT. And then lastly, we've got a vector. So this is a little bit more interesting. So here we can see that we've used a single AND sign and a single vertical bar. That's because we're comparing two vectors. So the double is used when you're comparing to what's called scalars, so single numbers. And the single one is used when we're comparing entire vectors. So this is actually going to look through and it's going to compare these numbers, these numbers, these numbers, and these numbers. So for the AND statement, it's going to return 1 because they're both 1s. Then it's going to return 0, and then 0, and then 0, because for the rest of them, at least one number is not a 1. For the OR statement, it'll return 1, 1, 0, 1. So anywhere that there's at least one of them equaling 1, it will return true as well. The NOT A is just going to flip this whole thing. So it'll return 0, 0, 1, 1. So we'll have a look at that as well. Just need to tweak the code slightly. So 1, 1, 0, 0, 1, 0, 0, 1, and just get rid of those scalar form operators. Run the code, and we can see that, as we expected, the AND statement is only true for the first one where we had the two 1s, and the rest of the time it's false. The OR statement is true for all of them except the one where there was 2 zeros, because that's the only time that'll be false. And then the final one, which is the not A statement, has just flipped the values of A. So that's our and, or, and not in MATLAB. Next up, we're going to have a look at testing multiple conditions. So this is a bit of a fill in the blanks exercise. So I'll start by writing the code that we've got in the template up. So this one we're looking at the cost of the car being $10,000, and the car has driven almost 100,000 kilometers. So what we're looking for is for the car to cost less than 15,000 and have driven less than 100,000. So that's just taken from that display message. So we want to be checking for both those conditions. So if car cost is less than 10,000 and the car kilometers is less than 100,000, then display that message. And then finish off our if statement with an end statement. So with these current values, it's actually going to return nothing because the car cost is equal to 10,000 and we're checking whether it's less than 10,000. So if we run this code, oh, what have I missed? Oh, I forgot to close my bracket. Close that bracket up and it'll return nothing because the car doesn't cost less than 10,000. However, if we change this cost down to 9,000 and we run it, then we get that message. Oh, sorry, it was 15,000. That's my bad. Let's change that condition there to 15,000. So yes, that 10,000 will actually meet the condition and print the message. But yes, if we put the kilometers up or we put the cost of the car up, then we just get no message. So it only enters this if it's less than 15,000 and the car has driven less than 100,000 kilometers. So that's how we can do multiple conditions for an AND statement. Here we're looking at whether a number is within the possible range of months. So months can only have a number between 1 to 12. So we want to write code that kind of displays if something is not a real month. So let's get rid of this. And we'll copy the code. So we're going to put our actual condition there. So if we want to display only when it's not a real month, we can use an OR statement. So we can check if the number is less than 1 or if it's greater than 12. So we can go if month number is less than 1, so it's 0 or negative, which is not possible, or if month number, and notice how I have to actually type out the variable name each time. That's important to remember. So if or month number is greater than 12, then display that's not a real month. So pretty much if the month number is 0 or negative, or if it's bigger than 12, then we'll get this message printing on the screen. So at the moment it's set to 4, which means that when I hit run, we should just, yeah, I didn't put a semicolon there, so we just see the month number, but we won't actually see that message print. If I set this to 13, I'll get the message saying this is not a real month. If I set it to 12, it won't print the message, it'll just print the number because I forgot to put the semicolon. If I put in -1 as the month number, I'll get the message saying it's not real. If I put 1 in, I don't get the message. So that's sort of a little bit of an example of how you might test that too, sort of testing those edge conditions to make sure everything's working as expected. So that's OR statements in if statements. And now we're moving on to repetitive processing. So we're going to have a look at for loops in exercise 5 and then while loops in exercise 6. So let's start with the for loop. Let's get rid of all of this. So we want to write some code that counts down from 10 to 0. Now we want to display the number as the countdown is happening. When the countdown reaches 0, we're going to display the message liftoff. So it's a rocket countdown. So we're going to have a vector, pretty much. We're going to create, so for I equals 10 to -1 to 0. So remember from earlier, we had a look at what this vector actually looked like. So I'll just clear all this. So this vector actually looked like 10 to -1 to 0, a countdown from 10 to 0, which is exactly what we're trying to achieve. And sorry, I'm just going to take a quick detour and increase that font size a little bit so it's a bit easier for people to read. All right, hopefully that's a little bit better for anyone who's watching this. So what we're doing here is we're saying for I is equal to all of the values in this vector, and then we're going to perform some behavior. So in this case, you want to actually display the I value and then end our for loop. And then after it reaches 0, we want to print that message of liftoff. So if I run this now, you can see that it's generated the numbers 10 through to 0 very, very quickly. It's not much of a countdown like this. There's actually a little function you can use called pause, and you can give it a value in seconds, I believe, that will actually pause it briefly so that you can see that. So we could also do it as seconds. And then you'll sort of see that gradual countdown a little bit more clearly. So that's an interesting little function that might come in handy for your assignment as well. So hopefully that's clear. It's stepping through each of those values in that vector of 10 to 0 in steps of -1, and it's displaying it as it goes, and it's taking a pause between each number before moving on to the next one. And then once that repetitive processing ends, the code moves on and it displays this message. So that's a for loop. So for loops are useful when you know how many times you need to repeat the code. While loops are useful when we don't know how many times we have to repeat the code. So a really common example of where while loops are used is in getting user inputs, because we don't know how many times a user will input the wrong value before they put in the right one. So in this example, we're looking for the user to input a positive number. If they input a negative number, we want to display an error message and ask the user to input the number again. So we want to repeat this again and again and again until they input a positive number, and then at that point print a message that says the square root is, and print the square root. So we'll start off with our user input line. So we're going to get our user input. And then we're going to enter our while loop. So while the user input is less than 0. So this is saying while the user input is negative, get the user input again. So we can put in a little error message. And then we end our while loop. So effectively what's going to happen here is it's going to get stuck in these 3 lines of code for as long as it takes for someone to enter a positive number. So it'll stay in here until someone enters a until someone enters a positive number, and then it'll move on. So the code that appears in line 6, 7 and beyond will only run once the user has actually entered a positive number. So at this point, we can put in our line that says, well, we can maybe calculate the square root first. So result equals the square root of user input. And then there's a few ways we could display the message. So we could use display with string cat. So this is string concatenate, it's short for. So this is how you can combine multiple strings. So you could do the square root is equal to, and then use num to string to convert the number result to a string. That's one way, perhaps a little bit confusing. Another way is to use another formatting function called fprintf. So fprintf allows you to create a message with some format and leave placeholders for values. So the square root is equal to %.2f. So that %.2f says this is a placeholder for a decimal number with 2 decimal places. You could also do %d, which is a placeholder for a decimal number. You could do %s, which is a placeholder for a string. But in this case, we probably want a floating point number. A decimal number, which is also called a floating point number. We might also have different numbers of decimal places, so you could do 3f if you wanted 3 decimal places. And then we just give it the number that we want it to use. So when we run this, it'll say, please enter a positive number. I'm going to give it a negative number. It's going to give me an error. I'm going to give it a negative number again. I can do that for as long as I want to. And then when I've had enough of that game, give it a positive number. And it'll give me those two different message formats. So you can see that the string concatenate version has kind of done its own thing with the decimal places, whereas the fprintf version has done the 2 decimal places that I asked for. Same result, 2 different methods. I personally prefer the fprintf format. I find it's a lot easier to get it to look how you want it to, but both are valid options. So that's our while loop example. Next up, we're going to have a look at a bit of an example of converting for loops to while loops. So this is actually our for loop from before. You might have jumped ahead and noticed that when you were answering these yourselves. But now we're going to actually have a look at converting this to a while loop. So let's get rid of this one. So what we want to do is we have to start with our starting value of I. So if we have a look at our for loop, I is going to go from 10 to 0 in steps of -1. So our starting value of I is going to be 10. And then we want to repeat that until I is equal to 0. So we want to repeatedly subtract 1 until I is equal to 0. So while I is greater than 0, we want to take I and subtract 1 from it. And then we want to actually display that. Actually, we'll want to put the display message beforehand. And then we can end that and display liftoff. And there's actually going to be a small problem with this code. I'll run this first so I can show you. So I'll actually put the pause in, just a little pause. And we'll open up MATLAB and we'll see it count down. So it actually gets to 1. It doesn't print the 0. Whereas in our for loop from before, we did actually print the 0 before printing the liftoff. The reason it does this is because it's gone while I is greater than 0, display I, and then subtract it. So a couple of ways you could work around this. One way would be to put a final display statement here, and then it'd count down and print that 0. Another way would be to let this be while I is greater than or equal to 0, because then it'll run one last time when it is equal to 0. However, I will be set to -1 at the end of that. So it just depends if that's going to be okay with what the rest of your code needs to do. So I'm probably going to do it this way. But yeah, if you came up with another method, that's okay. So that's going to print the kind of full expected result. So the reflection question was, is a for or a while loop more suitable for this problem? Generally speaking, a for loop would be, because we know how many times it needs to repeat. So for loops are the go-to method when we know how many times we need to repeat a function. While loops are the go-to when we don't know how many times we need to repeat a functionality. So when we're getting user input, or if we have an unknown number of files that we want to read through, that's where we would use a while loop. Anything you can write as a while loop, anything you can write as a for loop, you can write as a while loop. However, not everything that you can write as a while loop can be written as a for loop. So you can always translate a for loop to a while loop, but not necessarily the other way around. And then we were also introducing some new keywords around loops this week. So we've got the break keyword in exercise 1 and the continue keyword in exercise 2. So in exercise 1, we've got this array that's being created. And then we're going for I in 1 to length A. So in other words, for each element in A, we're going to check that the ith element of A is greater than 4. And if it is, we're going to break. Otherwise, we're going to display the ith element of A. So what's going to happen here is it will go through. So the first element of A is 1. So it's going to be initially checking if 1 is greater than 4. That's not true, that's false. So instead it'll run this. It'll display the ith, or the first element of A, so 1. Then it's going to check the second element of A, so that's 4. So it's going to say, is 4 greater than 4, which is false. So it'll instead display 4. Then it's going to go to the third element of A, and it's going to say, is the third element of A, aka 5, greater than 4? In this case, it's true. So the code's going to break out, and that's it. The code's going to finish running. So all we're going to see displayed is 1 and 4. And again, we can head over to MATLAB to verify that. So I'll put in the same array. That one doesn't want to indent properly for me. There we go. Oh, that's because I've typed 4 instead of if there. That's why I didn't want to do it properly. That's my bad, actually. Alrighty, so if we run that code, we should see that output that we were talking about, 1, 4. So that's how the break keyword works. So once sort of the break is encountered, it exits out of the loop altogether. Nothing further runs. Continue is a little bit different. So with continue, if it encounters a continue, it effectively skips the rest of that iteration of the loop, but it continues from the next one. So we'll talk a little bit about how it's going to work. So we've got A equals 1, 4, 5, 3, 1 again. So our code is going to check the ith element of A against 4. So it'll start with element 1. Element 1 is not greater than 4, so that statement's false. So it's going to display 1. Then it'll check element 2, which is 4, and it's going to say if 4 is greater than 4, which is false, so it's going to display 4. Then it's going to check the third element, which is 5, and it's going to say if 5 is greater than 4, which is true, so it's going to continue. So continue means it skips anything that's below there, but then it goes back to the next item in the loop. So then it is going to move on to 3, and it's going to check if 3 is greater than 4, which is false, so it'll display 3. And then it's going to move on to the fifth and final element, which is 1, and it's going to say if 1 is greater than 4, which is false, so we'll be displaying 4. So we can check that. I only need to change one line of code here. And we can run this one, and we'll see that it's printed those numbers that we talked about. So 1, 4, 3, 1. The only one it skipped was 5, because 5 was the only one that was greater than 4. So the way that it's different is that the loop continues to execute after a continue, whereas the loop ends for a break. So there, might be different cases where you use each of them. You might want to break out if you encounter some erroneous data that's going to affect some math that you're doing. Or you might want to continue if you've got mostly good data and only 1 or 2 of them are out and you're processing each one individually. It would just depend on the application. So I might just quickly mention, another way you could have written this overall logic. So you could go for I equals A, or for element equals A, or something like that. Let's just go with for I equals A. And then you can go if I is greater than 4, continue, else disp I, end. So what we're doing here is instead of setting it to, so this one here sets it to the indexes of the array, so 1, 2, 3, 4, 5. This one sets it to the array itself. So it checks sort of each element individually. So if I run that, they're going to have the same output. So that's from the first loop, that's from the second loop. So if you're stepping through every element in an array, you can write it this way if it makes more sense. I personally prefer this way because you can sort of see that it's an index of an existing array, and you can also reuse this code for some other array. Like if I change the length of A and stuff, it sort of still makes sense. I guess that, yeah. It's up to you which one you prefer. I prefer this one, but if this works for you, that's also perfectly acceptable. So starting off with cell arrays, this first question is pretty much looking at how to create and also index cell arrays. So cell arrays look like this. They've got the curly brackets and they can contain multiple different types of data. So here we have a character array or a string that says hello. We've got two numbers, one that says 22 and one that says 10.2. So this is the main advantage of cell arrays. It's the fact that we can contain different data types and also different data lengths. So you could have a series of strings that are all different lengths, for example, which is not something that's achievable with the standard arrays that we've learned in previous weeks. So let's firstly just, before we answer any questions even, I'm just going to copy this into MATLAB so that we can see what the structure looks like. So when I run this, I'm going to leave the semicolon off so it actually prints. You can see that the cell array contains 3 cells. The first cell contains that character array hello. The second cell contains an array of numbers, but the array is only one value, it's 22. And same thing with the third cell. We've got this array of numbers, but it's actually only one number, 10.2. So that's sort of what a cell array looks like if we break it down and print it out. And the questions are asking us to pull specific things out. So the first one says, what would A1 return? So, and notice that it's the squiggly brackets. So that's saying what is in the first cell of the cell array A. So if we type that in, A squiggly bracket 1, that's going to pull the first element, the first cell out, which is this entire string. So if I run this now, we'll see that we get that hello from that A1. So then B asks us, how would you extract the integer number 22? So if we go over to our code again, that number is in the second position. So we can go A2. Probably should leave the semicolon off. There we go. The other thing is, before we saw that it's actually storing it as kind of an array of numbers. So you could have an actual array of numbers in here. So I could have replace that 22 with an array of 2 numbers. So then that A2 would return the whole array. And then you could pull out specific values using just smooth round brackets. So if you wanted the second element of the second cell, then you would go curly brackets 2 to get the second cell, round brackets 2 to get the second element of that cell. And that's how you would get that number 23. I'll just return that to its original state. And then let's have a look at question C. So question C says, what would A curly brackets 1 round brackets 5 return? So this is, again, doing pretty similar to what we just looked at with the numbers. It's saying, I want the first cell, curly brackets 1 means first cell, and I want the 5th element of that cell. So if we have a look at the first element, that's that character array hello, and we want the 5th element of that first cell, well, that's 1, 2, 3, 4, 5. That O is the 5th element. So if I go A1, 5 and run that, we'll see that we get the letter O. So that's our first question. Let's have a look now at our second question. So this one uses some nested cell arrays to print a series of messages that are all in the same format. So firstly, let's have a look at what the code is doing. So this first line, name and scores, is creating a cell array of cell arrays. So there's 3 cells, 1, 2, 3, and those are actually showing the, those are containing a name and a score. So each cell, or each of the 3 cells, contains 2 values itself. So we call that a nested cell array because cell array is inside cell arrays. So what this for loop is then doing is it's saying for I equals 1 to the length of name and scores. So that's saying for each element, for each cell in the overall cell array. So that's going to actually be 1, 2, 3 because there's 3 cell arrays within the overall cell array. So for each of those 3, we want to print this message. And just as a bit of a recap of fprintf, the way that fprintf works is that we kind of create this message structure and we put placeholders in to replace with actual values. So %s is saying there's going to be a string here, and %d is saying there's going to be a number here, a whole number. And the backslash enters new line, so it goes to the next line rather than continuing on the same line. So then the actual parameters after that, so this first one here will be what replaces the first placeholder. The second one will be what replaces the second placeholder. So this is going to be our string. and this is going to be our whole number, our score. So most of the code's written, and I've already rewritten some of it in here. I've just left those blank, just like they are in the question. So we know that I is going to be 1 to 3 because there's 3 cells. So we're going to get the ith cell, so either cell 1, 2, or 3, depending on the iteration. And then we want to get the first cell within that. So we want to go to the ith cell, which will be this one. And then we want to get the first part of that, which will be the name. And then we'll want to do the same sort of thing here with the score. So I and 2, which is going to say, let's go. So on the first iteration, for example, it'll say, let's go to the first one and get the second part. On the second iteration, we'll go to the second one and get the second part. On the third iteration, it goes to the third one and it gets the second part. And that's going to result in this expected output that was given to you in the question. So if we run this now, we'll see that we get that same thing. In the actual question too, it had kind of this extra one with the round brackets. So you can put 1 there and it'll still work because it's extracting the first number from a number array. It just so happens that that number array only contains 1 value. So if I run this now, we still get the same result. So that's how you would fill it out to have the exact same format as the sample code. So that's cell arrays. Hopefully that's pretty clear. You could also have a bit of a play around with what these look like by just printing different parts of it. So you could go, I want to have a look at all of these different things. 1, for example. And if you have a look, you'll see that when you print the whole thing, it just says it's a 1x3 cell array that contains 3 1x2 cells. And then the next one that I looked at was name and scores cell 1. So that says cell 1 is a 1x2 cell array that contains these things. And then the last thing I called was name and scores cell 1 element 1, and that retrieved this gym. You could even go one step further and say I want the third letter of that, and you would get M. So just paying note to where curly brackets are used and where round brackets are used is the biggest challenge of cell arrays, but hopefully this example has made that a little bit clearer. So question 3 is on structures. Structures are kind of a table type, database type way of storing information. So let's have a look at this code first. Again, I've copied it out in advance. So we've created this structure called student. And then we've said student 1's name is Jan, his age is 23, and his degree is IT. Now the question asks us to add a second student named Lara, 19, studying engineering. So the way we can do that is just to go student 2, use those same fields. So name is Lara, student 2's age is 19, student 2's degree is engineering. So that's going to add the student, and we can check that a few different ways. So firstly, let's just print the whole structure, so the whole student structure. So if I run that and I pop over to MATLAB, we'll see that it says it's a 1x2 structure array with these fields. So that's saying there's 2 records, 2 students. 1x2 means 2 students. And the fields that we have for that is name, age, and degree. So it kind of provides you an overview of what that database contains, the sorts of things that the sorts of information that it holds. So we can also extract a specific student. I can go display student 2, and that'll give me all of the fields for Lara. So it'll give me her name, age, and her degree. And I could also extract a certain value on that student. So I could go, what's student 2's name? Student 2's name is Lara. So that's our structure format. Pretty handy if you need stuff to be really understandable, because it's a little bit more human readable than a lot of our other data storage types, because you can sort of relate that to like a table or a database that you may have seen, before. So a little bit easier to understand. Our last exercise for this week is one on working with dictionaries. So in part 12, we've been asked to create a dictionary that maps the name of a few different fruits to a corresponding price per kilogram for a list of these different fruits. Then once we've created that dictionary, we're also going to modify it a little bit. So first things first, creating it, let's go with fruit prices as our variable name. And to create this, what we're going to want to do is essentially call the dictionary function, and the first array will be the list of strings for the different names of the fruits. So bananas, apples, and mangoes. And then from there, we create a second array. So close that array off, and then our second input is the array of prices. So 2.5, 3.5, and 10 was the 3 prices per kilogram. Close that off with a close bracket, and I might leave the semicolon off so we can see it. And there we have our different fruit prices. So that's our definition line, and that's the result. And then if we wanted to do things like see what the price of apples was, for example, we could go fruit prices, apples, sorry, prices, Mr. Ness, and it would tell us that they were 3.5 or $3.50. So then, once we've created this, we've then been asked to do some modifications. So we want to write additional code to create a new fruit. And to do this, all we need to do is type fruit prices and what we want the new key to be. So we want the new key to be lychees, and we're just going to let that equal 22. So when I update that there, you can see that lychees has now been added into our dictionary as a new key with a value of 22. Then we want to update the price of bananas as the last part here. So again, we just go fruit prices, put the key in, and we just assign the new value. So we want it to now be $4 a kilo. Pop that in, and you can see that bananas there, where it was 2.5 before, has now been updated to 4. One that wasn't in the exercise, but I'll give you as a bonus, is if you wanted to remove something, then you can go fruit prices and the name of that thing you wanted to remove. So let's say we wanted to get rid of mangoes because they're out of season now, and we just let that equal an empty array. And you'll see now that the mangoes have fallen out of that dictionary. So that's some basic manipulation you can do. There's also a few functions that you can use with dictionaries to like loop through the different keys and values and stuff like that, but just have a look at the help docs for the full details on that. So that is it for this week's extra exercises. I hope you found it helpful, and I'll see you next week.